All right, everyone, welcome to Lab. Joe here. I'm here to go through Lab 4 with you, which is stellar properties. We're going to look at the properties of stars, particularly the brightness and distance, and we're going to look at the relationships between them. We're going to take some data, have you graph it out, analyze it a little bit, and then I'm going to show you what it looks like for gases to emit particular wavelengths of light. We're going to look at some emission spectrums from gases and relate that to what we see in stars. So stellar properties starts now. All right, so part one of the lab today deals with the light intensity at different distances. And we note that there is a mathematical relationship between brightness and distance. What you see in front of me is the setup for the first part. I have a light, which is going to represent our bright star, and then a dimmer to bring it down to a dim star. I also have a light meter, a lux meter, to measure light intensity. And we're going to take data on a bright star and then on a dim star, and we're going to graph that data and analyze it in part two of the lab to really explore the relationship between distance and brightness. So come on with me. I'm going to take the data from the lux meter at this time. All right, so I'm going to measure the light intensity at different distances away from our bright star here, which is going to be represented a star of a particular brightness. In this case, it's a 60-watt light bulb. Okay, you'll see that I have the lux meter here, and I'm going to give you readouts and measurements of the light intensity at different places. So here we go. Starting off with the first data point. When I have the first data point, I'm going to put that lux meter right up to 0 centimeters away, and my lux measurement is going to be about 17,000. So 17,000. So on the first data point for bright star, next to distance 0 centimeters, we're going to write 17,000 lux. The next one is at 5 centimeters. And so at 5 centimeters, 16,700 lux. So I'm going to write that in next to 5 centimeters. Now I'm going to go ahead and go through and take the data for the bright star and then take the data for the dim star and then show you the results. Okay, I'm going to try to dial down the sun to a dim type star now, or dial down our star to a dim star. And you can see the light intensity going way down here. Now I'm going to take the data for the dim star. And the intervals of space are a little different on this one because it is a dim star. So here we go. All right, everyone, here's our bright star and dim star data. So go ahead and pause the video at this time and write down this stuff into your data tables. All right, everyone, part two of the lab involves graphing this data from part one. So please go ahead and note that on the bottom of your graph here is distance in centimeters, and on this side of the graph is magnitude in lux. Now, the only thing about this is that you're going to have to make your own axes on this graph and on the dim star graph. That said, you're going to want to make sure that your intervals on the graph are equal. Okay, you're going to be tempted to kind of change your units here as you go through, but don't do that. If you have a data point that's way up in the tens of thousands and then others that are down in the hundreds, you really have to start up at like 20 or 30,000 up here and then go to 20,000, 10,000, 5,000 or something like that, 15, 10, 5, etc. So make sure that your interval is the same for both graphs. Once you graph this in part two here, part three is going to be analyzing the material that you graphed and analyzing the data that you took. So go ahead and look through part three and complete that using your data in your graph. In part four of the lab here, we're going to talk about how the spectra of stars tells us what is inside the star. when you take a star's light and you split it up into the spectrum, what you're going to notice is that it is a rainbow spectrum, and this is a very grayscale rainbow, sorry for that, but the rainbow spectrum actually is going to have black lines running through it. What that is that there are gases that surround the core of a star, and as the core of the star produces energy, that energy is filtered out away from the star, and the gas envelope around the star absorbs some of those energy wavelengths. And what it does is that the elements that are in the outer envelope of that star will absorb the specific wavelengths that it likes to make their electrons jump from one level to the next level. And so when it happens, it lets the rest of the light go through. And so what you're left with is this rainbow spectrum with these lines missing. And these tell us what elements are taking energy. We know what elements like what kinds of energies. And so when we see this pattern, we're able to, just like a fingerprint, figure out which elements are in the star's outer envelope. In order to examine this relationship, I have an emission spectrum activity for you. And this is using an electrode tube. And what we're going to do is we're going to send electrons or electricity through a gas. It's going to heat that gas up, and the electrons are going to make that gas absorb the energy. And the gases, again, will just absorb whatever energy levels are going to make their electrons jump. And then when they relax back down, they're going to release a color. And so our emission spectrums are different than our absorption spectrums in stars. Emission spectrums just give off only certain wavelengths of light, and those wavelengths of light blend together to give the overall color of the gas. And so in this part, what I'm going to do is illuminate a gas tube, and we're going to get a general color for the gas tube. And then I'm going to show you the view through the spectrometer, where we split up the light waves. And you're going to see that this gas really only has certain wavelengths of light that it gives off. And when you put those, kind of blend those together, and you get the overall color of the star. All right. And then for the, and I'm going to show you the spectrum, emission spectrum from the gas, and you're going to kind of draw in the lines where you see them in the little spectrometer. And then once you do that, you're going to compare it with a spectrum chart to see what gas it is. And you're going to do this for gas tube number 1, and you're also going to do this for gas tube number 2. Okay, and I'm going to just give you a big hint that I picked the 2 gases that are most abundant in stars, and that would be hydrogen and helium. So you have to figure out which is which. Is gas tube 1 and 2, either of them is going to be hydrogen or helium. So you're going to have to figure that out. Finally, you're going to take that information and use it to help you answer the questions here in part 5 on the absorption spectrum. Now, don't worry, there's a mathematical equation. It's just a plug and chug. You're finding out in here the peak wavelength of the stars, and in this graph, you'll find also the peak wavelength. It'll be like 410 nanometers here. You'll plug that in there, and you're going to kind of try to find the temperature. And once you find the temperature, you're going to be able to relate that temperature to one of the spectral classes of stars. Now, I'm going to give you a hint. The temperature of this star is very hot, that we see here in part 5. So when you go to classify that star in part 6, it's going to be the hottest of the star classifications. All right, so I've given you lots of hints for parts 4, 5, and 6. I'm going to now show you the emission spectrums for those parts. All right, here we have our electrode tube in the electrode box. This is the electrode box, and then the tube goes in here, and electricity goes through the gas, heats up the gas, makes it glow, because as the electrons pass through the gas absorbs the energy. The electrons jump to their higher level, and then when they relax back down, they release this color. So the overall color of this particular gas tube is pinkish. And you can see here the spectrometer. The spectrometer helps us to split those light waves into different wavelengths so we can see them. This is Prism here, and it provides a little bit of information about your particular wavelengths of light seen in what types of gases. And it's got a little scale in the back here to use. So we're going to use this apparatus here to figure out what emission lines are being given off and therefore what gases this is. When we spread out the gas spectrum, we'll be able to see what particular light waves are being given off here. All right, so we're going to begin. This is tube 1. The first tube is overall pink color, and we're going to go ahead and look through the spectrometer now to spread out the light waves into their different energy levels so we can see what this gas is emitting. All right, this is what gas 1 looks like. Through the spectrometer, you can see that just under 500 nanometers, we have a blue line, and in between 600 and 700 nanometers, we have a red line. So go ahead and draw those in on your lab. Okay, this is the best I can do for tube 2. You can see that when looking through the gas tube, or the spectrometer to see the gas is emitting particular wavelengths of light. We've got a couple there between 600 and 700, an orange and a red. We've got a yellow and a green between 500 and 600, and we've got a blue, a really pretty blue, right between 500, or right on 500 and just below 500. There's also some purple light in there. So please go ahead and draw in these light lines at the different wavelengths. Okay, you see our emission spectrum chart here. This is how you're going to identify which gas is which. Note that I'm showing you both hydrogen and helium. One of the gas tubes is hydrogen, the other is helium. You're going to compare the emission lines that you drew with the patterns you see here to tell which gas is which. You'll line up, you're going to look for the lines that you drew that match up with the lines on at particular nanometer lengths here in each one of these to try to figure out which gas is which. I only showing you hydrogen and helium because you either have hydrogen or helium there in your gas tubes. There are others though, as you can see, neon, mercury, nitrogen, they all have their own specific patterns that indicate to us that those particular lines are the electron levels of each of those gases. When electricity goes through them, the electrons get excited, and then they relax back down and release colors at each of these little wavelengths, because each atom prefers its own electron levels and its own energy levels. All right, well, thanks for joining me for the lab today. I hope you enjoyed it. Hopefully you picked up that there's a relationship between brightness and distance of stars. It is a mathematical relationship. The inverse square law applies. We also were able to look at the emission spectrum of stars and noted that gases like hydrogen and helium will, when excited by electrons, have their electrons jump to another level. When they relax back down, they release specific colors related to that particular energy jump. And so that's what I was hoping to get across to you. And then we finally looked at some stellar classifications, those spectral classes of stars, and how when we look at a star, we can actually tell what it's made of based on its absorption spectrum. So thanks for joining me today for the lab. If you have any questions, don't hesitate to email me, and we'll see you next time.